Hi, welcome back. In example one here, we're just going to look at graphing reflection. So we're going to start with a base function this time of root x plus 2. Okay, so I know usually our base functions are just root x or x squared, but this one we're just using root x plus 2 as the base. So it says write an equation and represent each of the following. So we got these three scenarios here. We're going to write equations for them. We're going to sketch them, and then we'll state the domain and range of each one. So, okay, let's get this started. So h of x is a reflection in the y-axis. So we'll do the first one in blue. So h of x is going to take f of x and it's going to reflect along the y-axis. So a reflection on the y-axis means that x needs to change to negative x. So f of negative x means I got to take negative x and I got to replace it inside of there. So we would have root negative x, and then we still have the plus 2. So that is my h of x equation. Okay, I like to sketch this now. I could just go ahead and sketch this, but I'm actually going to work with the base function and show the transformation. So the base function we'll do in black. We'll call it f of x. It's root x plus 2. So this will be our table of values for this. So um, I'm kind of taking those key points that we used before with root x, and I know the y values for those, but this one is plus 2, so I just got to add 2 to them. So my 0, 0 becomes 0, 2, 1, 1 becomes 1, 3, and 4, 2 becomes 4, 4, and 9, 3 becomes 9, 5. So basically what I did is I just did a vertical shift on the base function root x. But anyway, those are our base points. We want to map them over, okay, to a new set of points. So we're going to map them over to h of x. So when we reflect along the y-axis, the x values become opposite sign, and the y values stay the same. So all I'm going to do is grab these, plug them into that negative x. So basically just take their opposites. So 0 stays 0, but all the other ones get a nice negative sign on them. Okay, y values stay the same. So we can actually see there is a point that didn't change here. This one, 0, 2, right? That actually remained the same. We call that an invariant point. Invariant point. So invariant points are points that don't change during transformations. Okay, so they remain the same. They're called invariant points. Okay, I think we are ready to graph. So let's get our y-axis in here. I'm going to kind of pick close to the middle here. The y-axis. The x-axis, I can draw this a little bit lower. Try that again. Okay, there's our x-axis. I'm just drawing it a little bit lower because we have the plus 2, right? So my base function is up a bit higher, and the reflection will end up being a little bit higher too. So let's get the base graph in first. We got 0, 2, and then we got 1, 3. That'll be here. And then we got 4, 4. That'll be here. And then our 9, 5. That just fits in right there. That's f of x. Okay, it's essentially root x shifted up 2 units, right? Okay, now our transformed one, all the x values get opposite sign. There's our invariant point, and we got negative 1, 3, negative 4, 4, and then we have our negative 9, 5 right there. Okay, just carefully draw that through and then label it. Okay, we can call that one done, right? So one thing I just want to point out that these are always equidistant. Okay, when we reflect along the y-axis, we're basically taking whatever's here and we're folding it along this line, and it maps over directly over like this. So think of like closing up a book, right? And if this was a wet ink and you close onto a blank page, it would imprint directly over. So that is a reflection in the y-axis. Last thing we need to do is just state the domain and range. So for the base function, x is an element of R, x is greater than or equal to 0. The range, y is an element of R, y is greater than or equal to 2. Okay, I said 2 because it begins here and then goes upwards, right? The transformed one, I think there's just enough room to fit this in. We'll say x is an element of R, and then x is, this time it's smaller than and equal to 0. Okay, the range, notice the range kind of became the opposite because the x values become the opposite. And the y values stay the same, and notice the range doesn't change. We're going to have y is an element of R, and we'll have y greater than or equal to 2. So when we reflect along the y-axis, only x changes. The y's end up staying the same. Okay. All right, let's look at our next one. We'll do this one in red. We have r of x, a reflection in the x-axis. So if we're doing a reflection along the x, I'm going to want this x-axis to kind of be situated in the middle here. And the y can be off to the side because our graph is just going to be positive. Okay, we'll write out, before we start graphing, we'll write out the equation. So r of x is a reflection in the x-axis. So it's going to take f of x, and it's actually going to multiply it by -1. That way it reflects along the x-axis. So that means r of x is going to be equal to a negative root. Well, sorry, we're going to write it this way. I'll show you the substitution. So we're going to have negative times an f of x. So f of x is root x, plus 2. Right? This is f of x, and r of x is a negative f of x, so we have to put the negative in front. Okay, be really careful with these. Make sure you distribute that negative all the way through. Okay, and we're going to get negative root x minus 2. Okay, so we can say therefore r of x equals negative root x minus 2. Okay, now our table of values. So we have our base function. We have f of x here. We're going to have the same key points. So 0, 1, 4, 9. And we're going to get 2, 3, 4, and 5. I kind of remember they always just go up by 1. So that was the same points that we had here. Okay, that's going to give us this graph here. 0, 2, 1, 3, 4, 4. That's not 4, 4. 4, 4, and 9, 5. Go 5 over from there. That would be right here. Okay, that's f of x. And now this is going to transform over to r of x. So when this happens, when we reflect along the x-axis, these points end up mapping down here. And the x values stay untouched, but the y values get an opposite sign. So we just write negative y. So I'm just going to copy these points over into here for x because they don't change. So we got 0, 1, 4, 9. I'm going to take these y values, I'm going to plug them into there, and we'll have -2, -3, -4, -5. Let's plug those in. We'll get 0, -2, 1, -3, 4, -4, and 9, -5. That's too many. 9, -5. There we go. Okay, and we'll go nicely through there, r of x. Okay. So notice these are nice and equidistant. Okay, so the space in between them with the x-axis is equal. Okay, that's how reflections, that's a characteristic of them, right? They'll always be equidistant to the reflection line. Okay, finally, we're just going to state the domain and range. So the domain is going to be the same for f of x. So I could copy and paste it, but I'm just going to write it out again. That's the domain, the range. Y is an element of R. Y is, oh, the x, actually, sorry, my mistake here. X is greater than or equal to 0. The y values are greater than or equal to 2. Maybe I should have copy pasted it. Okay, I'm just going to move that over a bit. And for the red graph, our domain, x is an element of R. X is greater than or equal to 0. Okay, this doesn't change because in this transformation, only the y values change. The x stays the same. So now we're starting at -2 and we're going downward. So my range, we can say y is an element of R. Y is smaller than or equal to -2. Okay, and that's it for that one. The next one is S of x, and they want us to do both transformations at the same time. So it says do a reflection in the y-axis, then a reflection in the x. So as you were kind of made aware during the investigation, the order doesn't matter for these. So, and you could even see, even when I write it out, there's no way of understanding the order either. So this one will be done in green. So S of x. So we're going to reflect along the x-axis and the y-axis. Okay, so this one here first, we'll say this one was like the red one we just did, this negative in front. So we'll say reflect along x-axis, and that one means to reflect along the y-axis. So this was like the blue one that we had done. So we're kind of just putting the two together. In order to do that, I'm going to make sure my axes are centered as much as possible. Okay. Let's go ahead, let's write out our equation. So we have S of x equal to negative f of negative x. So first thing I'm going to do is I'm going to replace, well, I guess we could all write it out all at once. So I'll put the negative sign first. That's from this part here. Then f of negative x, I'll have to write in the bracket. F of negative x means I'm going to have to take this here, and I got to replace x with negative x. So I'll have root negative x plus 2. Okay, so you can clearly see here, just by looking at this, x has been switched to negative x, like we have here. And then we took this whole thing and we multiplied it by a -1. That's what we have here. Okay, so that is the equation for S of x. We should distribute this negative in. Okay, so it's not going to go inside the root. We just put it in front. So we'll have negative root negative x. Then we have -2. Okay. No, these negatives don't cancel. This one's underneath the root, and then this one's out afterwards. Okay. All right, so let's get to graphing. Let's graph our base function. So we can steal all those points that we've been using, 0, 1, 4, 9, and then we started at 2, and then they went up by 1. Okay, that's f of x. Those are going to now map over, and this is so easy, this part. Like, if we reflect along the y-axis, well, our x values need to become negative. And when we reflect along the x-axis, our y values become negative. So literally just switch the sign of all those x and y values. So we'll get 0, -2, -1, -3, -4, -4, -9, -5. And it's as easy as that. The order does not matter that you do those in. And let's go ahead, let's graph. So 0, 2, then we got the next one, and then that was our 9, 5. Okay, once you get onto the third graph, you kind of get pretty good at plotting them. 0, 0, -2, that's here. And then we got -1, -3, that's here. -4, -4, that's here. And -9, -5, that's here. Okay, and just label it. So you can see like this is kind of both reflections happening at once. So if we would reflect along the y first, we would end up over here. And then when we take that and then reflect down this way, we would end up getting the green graph. Okay, so this is kind of doing both of them at once. One thing I will point out, when you reflect along the x and then the y, it actually kind of creates like a pinwheel effect. So if you always want to, if you're not sure if you graphed it right, think of this as like being pinned at the center, 0, 0 here. And if you were to spin this graph like it was a propeller, it would end up, the whole thing end up rotating and being here. So that's one way you can kind of think about it. I noticed the order did not matter. I could take the space graph and I could reflect along the x first, and I would end up down here. And then I could take that red and fold it over the y-axis, and it would end up over here. Okay, lastly, we got to do the domain and range. So our x is an element of R, x is greater than or equal to 0. The range, y is an element of R, y is greater than and equal to 2. Okay, that's what we've been using for the base function. The transformed one, notice x and y both change. So x is an element of R, x is now less than and equal to 0. So that's everything this way, everything smaller than 0. And the range will be at -2 going down. So that one's going to change as well. Y is an element of R, y is smaller than and equal to -2. Okay, thanks for watching. I'll see you soon in the next example.